Hi, in this video, we will talk about the product rule and the quotient rule. Okay, so a lot of students, when they start working with the product rule, like if I have the f times g, okay, when they take the derivative of this, they feel that, oh, is this equal to f prime of x times g prime of x? Okay, unfortunately, this is not working this way. Okay. So let's see how do we actually work with the product rule? Okay. So to take the derivative of f times g is we take the derivative of f first times the g functions plus the f function times the derivative of the g. Okay. So in the prime notations, so it's look like f prime g plus fg prime. Okay. So if we have three functions, f times g times h, okay, if we take the derivative of this, then it is equal to f prime times gh plus f times g prime times h plus fg times h prime. Okay, so you will see the pattern. This pattern right here, it seems that we take turn to take the derivative, then. Okay. Okay. So now let's see how we actually get the derivative of a product then. Okay. So first, we would like to let j of x equal to f of x times g of x. Okay. Then, if I want to find j prime of x, then we could take the limits h go to 0 of j of x plus h minus j of x over h then, right? So we go back to the limit definitions. Then now, so the j function is f times g, so I will have f of x plus h times g of x plus h minus f of x times g of x over h. Okay. Then now, what I need to do, I would like to add some terms, okay, to help me to work with the limits then. Mhm. So now I will subtract f of x times g of x plus h, and I would like to add it back. Okay. And then now f of x times g of x all over h. Okay. Okay. Then now I'm going to rewrite this into two limits. And now you will see that we have a common factor. Okay. Same thing with this limit right here. Okay, so now I would like to rewrite this a little bit Okay. Okay. And now you will see that to this one, this is just f prime of x. And then as h go to 0, then I only have g of x here. And plus these I have f of x. Okay. And then to this one, again, this will be my g prime of x. Okay. So therefore, we just find out that the derivative of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x then. Okay. Now the quotient rule, okay, is again, if I take the derivative of f over g, it will be the derivative of f of x times g of x minus f of x times the derivative of g of x over g of x to the square. Okay. Now, if you compare the product rule and the quotient rule, then you will see that to the product rule is almost the same, but this one is a plus sign. To the quotient rule, this is a minus sign. Okay. So, and then to the quotient rule, we just need to have g of x to the square in the denominator. So then again, to the product rule, f times g prime is f prime g plus f g prime. Okay. However, to the quotient rule, f over g, okay, the derivative of f over g is f prime g minus f g prime over g squared. Okay. So, and again, if you want to prove it, it's really similar to the product rule. So you could try it if you want to. Okay. Okay. So right now, let us try to see how do we actually use the product rule and the quotient rule to help us to work out the problem then. Okay. Then let's try this problem. So to this one, again, this is, you could consider that this is the f functions. This is the g functions, okay? So again, f times g prime is f prime g plus f g prime, okay? So let's see how we work it out. So I would like to find f prime of x, okay? So first, I take the derivative of x to the power 3 plus 2x times x squared plus 5 plus x to the power 3 plus 2x times the derivative of x squared plus 5, okay? And now, the derivative of x to the power 3 plus 2x is 3x squared plus 2. And the derivative of x squared plus 5 is 2x. And now, what do I need to do is, I just need to expand it out, right? So FOIL this. So I have 3x to the 4th plus 15x squared plus 2x squared plus 10. Okay. And then we would like to add, this one will be 2x to the 4th plus 4x squared then. Okay. And now let us add like term. So this one, this one. So I'm going to have 5x to the fourth. And now I have 15x squared plus 2x squared plus 4x squared. So in this case, I will have 21x squared. And of course, I'm going to add 10. Okay. And in this case, okay, so this is how we using a product rule to help us to finish the problem then, right? Okay, so now it is your turn. Go ahead and try to see if you could find J prime of V then. Okay. So we start with J prime of V. Then again, we take the derivative of V to the power 3 minus 2V V to the negative 4 plus V to the negative 2. And we add V to the power 3 minus 2V and take the derivative of V to the negative 4 plus V to the negative 2. Okay. And now the derivative of this will be 3V squared minus 2 divided by V to the negative 4 plus V to the negative 2. Okay. Plus, okay, V to the power 3 minus 2V and multiply to negative 4 V to the negative 5 minus 2 V to the negative 3 then. Okay. Then now, remember when we have x to the n times x to the m, we are adding the power together, right? Become x to the n plus m. So then again, I have this one. Okay. So I will have 3 v to the negative 2 plus 3 minus 2 times v to the negative 4 minus 2 times v to the negative 2. We'd like to add. So I have negative 4 v to the negative 2 minus 2 plus 8 v to the negative 4 plus 4 v to the negative 2. Okay, so again, we are going to work with the like terms. Okay. So we will find out this one and this one. They cancel out. Then I will have v to the negative 2 so I will add 6 v to the negative 4 plus 1. Okay. Okay, so then this is the idea. And now let us look at our next example now. So again, to this C right here, I still have two terms. So therefore, in this case, before I work with the using the product rule, then maybe let me rewrite this into z to the power of 1 over 3 times e to the z, right? Okay. Okay, then now let's take the derivative now. So I have f prime of z is take the derivative of z to the 1/3 times e to the z plus z to the 1/3 times the derivative of e to the z. Okay. And now it will be 1 over 3 z to the 1/3 minus 1 times e to the z plus z to the 1/3 times e to the z then. Okay. Again, remember the derivative of e to the x is just e to the x, right? The derivative of exponential functions. And now I will have 1 over 3 z to the negative 2 over 3 e to the z plus z to the 1/3 e to the z. Okay. So right now, again, we are done with the derivative, okay? But right now, you will see that we have some like terms. So now I would like to introduce how do we actually factor out the like term, okay? So then remember when we try to work with the factoring, okay? So for example, if I have x to the power 4 plus x squared, when I try to factor, what we are looking for is we are looking for the kind of like the smallest power, right? We are going to take out the x squared, okay? Then what happened to when we take out x squared? Basically, you will see that what happened is we are going to subtract the power, okay, by the number that we take it out. In this case, if we take out 2, x squared, then I will have x to the 4 minus 2 plus x to the square minus 2 then, okay? So this is kind of like the idea, okay? And then when we simplify, then I will have x squared plus 1, right? So this is kind of like the idea. So now, when I try to work it out this problem, okay? Now, of course, in this case right here, if we have the same base, which is z, okay, then negative 2/3 is actually smaller than 1/3. So in this case, what I would like to do is I would like to take out, okay, again, z to the power of negative 2/3, okay. And of course, for e to the z, again, we could take it out e to the z, okay. And now, 1/3 is actually the fraction, right? We just also take it out, okay. Then let's see, how do we work it out after we take out 1/3 z to the negative 2/3 and e to the z, okay? Which is, again, this is the common factor that we have, right, to this one. Okay. Then now to the first term, we take out 1/3, then of course, we have 1 here, okay? We take out z to the negative 2/3 and then e to the z, that means I have 1 left, okay? Then now, what happened to the second term here, okay? You will see that if I take out 1/3, meaning I will have 3 left, because 3 times 1/3 give me 1 in this case, okay? So then now, what happened to the z, okay? Remember, this is z to the 1/3. So when we take out z to the negative 2/3, in this case, it means that I would like to subtract negative 2/3. Just like what we did it here. We take out 2, then we subtract 2. And of course, we also take out e to the z. So then now we are done factoring, right? Okay. Then now let's see, how do I simplify this then? So let's see. Let us work with the fraction. So in this case, I will have 3 in the denominator. This one will be z to the power of 2/3. Okay. And then of course, e to the z is on the top. Okay. Then I will have 1 plus 3. Again, 1/3 plus 2/3 is 1. Okay. So I have this. Then in this case, maybe we could rewrite this term right here. So I will have e to the z 1 plus 3c divided by 3 times cube root of c squared. Okay. Now again, the reason why I like to write it in this form right here. Okay. Remember, if I want to find the critical numbers, meaning when I try to set f prime of z equal to 0, then in this case, if I have this in the factor form, then I will be able to solve for z easier, right? If I stop it right here, then I may have a hard time to, again, solve this equation then. Okay. Okay. And now let's see how do we work with a quotient then. Okay. We have to apply the quotient rule. So remember the quotient rule is f over g. Then I will have f prime g minus f g prime over g squared. Okay. So again, this is my f functions. This is my g functions. Okay. Then I will have y prime is the derivative of e to the x times 1 minus e to the x minus e to the x times the derivative of 1 minus e to the x. And then all over 1 minus e to the x to the square. Then of course, the derivative of e to the x, just e to the x. The derivative of 1 is 0. So I have minus e to the x then. Okay. Now you will see that when we work with the quotient rule, most of the time we don't need to expand this, the denominator. Okay, just leave it alone. Okay. But we need to simplify the numerator then. Okay. So again, I will have e to the x. Okay. And then now think about this. If I have e to the x times e to the x, okay, meaning I will have e to the x plus x. So I have e to the 2x, right? So then I will have this is minus e to the 2x. Negative, negative, and positive, e to the 2x. Then of course, now these two cancel out. So then this is my answer here. Okay. So now go ahead and try to see if you could take the derivative of the next two functions then, right? So I have y prime, okay. Again, first set it up. So I will have the derivative of x plus 1, x to the power 3 plus x minus 2 minus x plus 1, the derivative of x to the power 3 plus x minus 2 all over x to the power 3 plus x minus 2 to the square. Okay. Then the derivative of x plus 1 is 1. And the derivative of x to the power 3 is 3x squared. Plus the derivative of x is 1. And the derivative of negative is 0, right? Okay. And now, what I need to do is I need to expand it out and simplify. Okay. 3x to the power 3 plus x plus 3x squared plus 1. So minus 3x to the power 3 minus 3x squared minus x minus 1. Okay. And now I would like to group the like terms. Plus x minus x 0. So I have negative 2 minus 1 is negative 3. Okay, so then let us look at the function f. Okay, now to this function, again, the problem f. Okay, so I have y equal to x squared over x plus k times e to the x. Okay, so in this case, the variable is x. So in this case, what is k? K is a constant, okay? Just a number. Then let's see. Y prime is the derivative of x squared times x plus k times e to the x minus x squared times the derivative of x plus k times e to the x over x plus k times e to the x to the square. Then I will have 2x times x plus k times e to the x minus x squared times the derivative of x is 1 plus, okay, again, the derivative of k times e to the x. Okay. Since k is a constant, so we could take out the k, and then we take the derivative of e to the x, which is e to the x. Okay, so then it's just k times e to the x then. And now, again, we try to simplify it. So I have 2x squared plus 2k x e to the x minus x squared minus k times x squared e to the x all over. x plus k times e to the x to the square. Okay. And now 2x squared minus x squared is x squared. And these two, they are not alike. Okay. So I'm done. Okay. Okay, so then now let's see how do we actually again use this product rule and also the quotient rule to work with the applications then. Okay. Okay, again, if the problem asks me to find the equation of the tangent line, okay, and the normal line, how do we actually work it out the problem? Okay, so let us review. If I want to find the tangent line, remember the first step is I would like to take the derivative, okay, of the function. So first I would like to find y prime. And then now I would like to find the slope of the tangent, in this case, at x equal to 1. Or we can use the notation is y prime, and then I would like to evaluate at x equal to 1 to find the slope of the tangent. And then number 3, we can use the Poisson form. Okay. In name is y minus y sub 1 equal to m x minus x sub 1. Okay. To work out the problem then. So if I want to find the normal line, then again, if we know the slope of the tangent, then we will be able to use the informations then to find the slope of the normal, which is negative 1 over the slope of the tangent then. And then, of course, the second step will be, again, use Poisson form. To find the equation of the normal then. Okay. Okay, so then now let's see how we work it out this problem. So I will have y prime. Okay, again, we take the derivative first. So I would like to take the derivative of 2x times x squared plus 1, then minus 2x times the derivative of x squared plus 1, then all over x squared plus 1 to the square. Then I will have 2 times x squared plus 1 minus 2x times 2x. And now I will find out that y prime is equal to 2 minus 2x squared over x squared plus 1 to the square. And now, let's see. If I want to find the tangent line, then go with y prime evaluate at x equal to 1. Okay. Mhm. We found out that well, the slope of the tangent is equal to 0. Okay. So remember the slope of the tangent, if it is equal to 0, what does this mean? It means that, again, if the slope is equal to 0, meaning we have a horizontal line. Okay. So the slope of the tangent is equal to 0, and then we have a point 1, 1. Okay. So this is the point, again, this is the curve y equal to 2x over x squared plus 1. Then at x equal to 1, 1, this point here, I have the slope, okay, of the tangent line is equal to 0. Then this means that I actually have a horizontal line here, okay. So therefore, in this case, okay, I will have, or we could use the Poynter sort of form, right? Y minus y sub 1 equal to 0 times x minus x sub 1, okay? Then, of course, in this case, we will have y is equal to 1. Then. This is exactly what happened. So this will be my tangent line. Is y equal to 1. Okay. Then now, I would like to find the normal line now. Okay. Then if the slope of the tangent is equal to 0, wow. Meaning the slope of the normal, it will be what? It will be undefined, isn't it? Because it's 1 over 0. Okay. So if it is undefined, well, then let's see. Sometimes we have to see, to think about what happened to if the slope is undefined. But one thing about this is remember the definitions of a normal line is we have a line that actually is perpendicular to the tangent line. Okay. Then basically this is my normal line now. Okay. So in this case, meaning my normal line is what? X is equal to 1, isn't it? So then this is my normal line. Okay, so this is kind of like a special case, okay? Okay. Then now, let's see how do we actually work it out the next two problems now. Okay. So right now, I have two functions. This is my f functions. Okay. And this is my g functions. Okay. And then right now, what I would like to do is, I would like to find u prime of 1. And what is a u function? U is equal to f times g. Okay. Then, now one thing about this is a lot of students make the mistake is when they work it out this problem right here, they work with the calculate, they start with the number 1, so they write down, oh, u prime of 1 is somehow is related to u of 1, then they evaluate u of 1. But again, this actually is not the right way to do this type of problem. Okay. So if I want to find u prime of 1, what is my first step, okay, is actually I need to find u prime of x first, okay? And then after we find u prime of x, then we replace x with 1 and then work it out the problem this way, okay? So then let's see. Then this is my first step. I start with u of x equal to f of x times g of x. Okay. Then now my step number 2, my u prime of x, basically it will be f prime of x times g of x plus f of x times g prime of x. Okay, so we work with the product rule to find the derivative of u. And then now we are going to substitute, right, to find u prime of 1, which is f prime of 1 times g of 1 plus f of 1 times g prime of 1. Okay. Then let us go back to the problem. Okay. What we need to do, okay, to A, or for A, we need to find f of 1, f prime of 1, g of 1, g prime of 1. Okay, those are what we need to find. Okay. So then, now of course, f of 1 is really easy to find because in this case, f of 1 is actually is equal to 2, right? As x equal to 1 to the f functions, I know that this is equal to 2. Okay. And do you remember what does this mean by f prime of 1? F prime of 1, it means that the slope of the tangent line at x equal to 1. Okay. Then now, okay, so how do we find the slope at this? Then we could actually look at the slope, right? Okay. From this point to this point. So basically, it's actually is we go up by 2 unit, rise, go up by 2 unit, and then we 1 by 1. Okay. So then in this case, f prime of 1 is actually is equal to 2. Okay. And then now, how about my g of 1? Okay. So again, this is the g function here. Then when x equal to 1, the output is equal to 1. So g of 1 is equal to 1. Okay. And now we're looking for the slope of this straight line here. Okay. So then in this case, it will be, again, you see, from this point to this point, we go down by 1 unit and 1 by 1. So therefore, in this case, g prime of 1 is negative 1. Okay. Then now we can go back to the problem to finish this. So f prime of 1 is 2 times g of 1 is 1 plus f of 1 is 2 times g prime of 1 is negative 1. Okay. So of course, in this case, you will have, okay, 2 minus 2. So the answer is equal to 0. Okay. Okay, so now try to use the same technique to see if you could, again, find out what v prime of 5 equal to. And So I have v of x is equal to f of x over g of x. Then v prime of x is f prime of x times g of x minus f of x times g prime of x over g of x to the square. And now I would like to find v prime of 5. So f prime of 5, g of 5 minus f of 5, g prime of 5 over g of 5 to the square. Okay. And now go to step 4. Okay. Then now I would like to find f of 5, f prime of 5, g of 5, g prime of 5. Okay. Then now 5 is here. So f of 5 is equal to 3. And f prime of 5 is, we would like to find the slope of this line. Then it seems that we go down by 1 unit and then 1 by 3. And now g of 5 is 2. Then the slope of this line is we go up by 2 unit and then 1 by 3. And now let's go back to the problem. So f prime of 5 is negative 1/3 times g of 5 is 2 minus f of 5 is 3 times g prime of 5 is 2 over 3 all over g of 5 is 2 square. Okay. So I have negative 2 minus 6 is negative 8 over 3 all over 4. Then, of course, to this one, we could multiply top and bottom by 3. Then I have negative 8 divided by 12. Or 4 times 2 and 4 times 3. So therefore, my answer is negative 2 over 3 then. Okay. We simplify it. Then now, let us look at our last example here. Okay. So again, I would like to find the tangent line to the curve f of x equal to x minus 1 over x plus 1 that are parallel to the line x minus 2y equal to 2. Okay. Okay, now you will see that this problem is really similar to one of the problem that we did it, right? From last section here. Okay. Okay, so now most of the time, again, the problem may not give you the graph of f. Okay, so therefore, again, to work it out this type of problem, to me, I always start with the graph of f. Okay, so therefore, again, I need to find a way to graph it out. Okay, again, you could use your graphing utility to help you to graph it. And now, remember to work it out this problem. Okay, what do we need to do is, because to this one here, they tell you that, okay, I would like to find the equation of the tangent line that parallel to this curve, this line right here, x minus 2y equal to 2. So what I would like to do first, okay, I would like to find, okay, the slope of x minus 2y equal to 2 first. Okay. Then in this case, okay, then maybe let us try to work it out. Then I will have x minus 2 equal to 2y. Okay. And then I could divide both sides by 2. So I have y equal to x over 2 minus 1. Okay. So then in this case, we know that the slope is equal to 1/2. Okay, so then now, since I have this, then why don't I sketch the function to see what is going on? Okay, so again, to this one, to this line right here, I have the y-intercept is -1, and the slope is 1/2. So is we go up by 1 unit and then 1 by 2. So this is my next numbers or next point. Then basically I will be able to connect them together. Okay. Then in this case, okay, so then you will find out that here, this one is the function y equal to x over 2 minus 1. Okay. Then now, so this one right here, what can I do here? Now again, because they would like to find the equation of the tangent lines. Okay. So then let's try to move it. Okay. So in this case, then here is one of the tangent line that touch the functions. Okay. Another one probably is this line right here. Okay. So then this is exactly these two lines right here. Okay. So this line 1 and then this line 2 right here will be what we are looking for then, those two tangent lines, right? Okay. Okay. Then in this case, we know that the slope of these two tangent line right here, okay? So again, one thing is I know that the slope of this tangent line right here must be 1/2. And also the slope of this tangent line right here, again, it must be 1/2 because they are parallel, right? And what I need to do, basically, I need to find this point, okay? And this point, okay? So if I could find the P1 and P2, then I will be able to finish the problem, okay? And now my second step is, okay, the second goal is I would like to find the 2 points. P sub 1 and P sub 2. What information do I know about this 2 point right here? I know that the slope of the tangent, okay, at P1 and P2 is actually equal to 1/2. Okay. So then in this case, what do I need to do is I just need to find the slope of the tangent line. Okay, so in this case, we know that the slope of the tangent line basically is mean that I would like to work with f prime of x, isn't it? Okay. And then what I need to do is I just need to set this f prime of x is equal to 1/2. Okay. When I solve the problem for x, then I will be able to figure out that what f p sub 1 and p sub 2 equal to then. Okay. So this is the idea. Okay, so then let's see how do we actually again continue to work it out the problem now. Okay. Mhm. So now I know that, okay, maybe I should say that now is I would like to find f prime of x. So if f of x equal to x minus 1 over x plus 1, then f prime of x is equal to the derivative of x minus 1 times x plus 1 minus x minus 1 times the derivative of x plus 1 all over x plus 1 to the square then, right? Then the derivative of this is 1. So I have x plus 1 minus x minus 1 times 1. The derivative of this is also 1. Which is equal to 2 over x plus 1 to the square. Okay. Then now, what I need to do, okay, is I need to set the 2 over x plus 1 to the square equal to 1/2. Okay. Again, we would like to set f prime of x equal to 1/2, right? This is what we would like to do. Okay. And now what we could do is we could cross multiply. So I have 4 equal to x plus 1 to the square. Okay. Then in this case, we could take the square root to both sides. Okay. But again, we have plus or minus, okay, of square root of 4. Then now I could solve for x, where we move the -1, we add -1 to both sides. Okay. So then in this case, I have x is equal to -1 plus 2, or x is equal to -1 minus 2. So x is equal to 1, or x is equal to -3. Okay. And now, if we look it back, it seems that to this problem, okay, so we have this one is x equal to 1 here, and then the location of P2 is kind of like x is equal to -3 then. Okay. And now, so we can work with finding the tangent line now. For L sub 1, Okay. So then we would like to find the point p sub 1, find p sub 1 when x equal to 1. Okay. So I have f of 1 is equal to 1 minus 1 over 1 plus 1. Okay. So then in this case, I have the point 1, 0. Okay. So then now I have the slope of the tangent is 1/2. And I have the point is 1, 0. Then I could use y minus 0 equal to 1/2 x minus 1. Okay. So this is my L sub 1. For L sub 2, we would like to find P sub 2 when x equal to -3. So f of -3 is equal to -3 minus 1 over -3 plus 1. So then in this case, the point that I have, it will be -3, 2. Slope of the tangent is 1/2. And the point -3, 2. Then I have, I run out of space, which is equal to 1/2 x plus 7 over 2. Okay. So my L2 is y equal to 1/2 x plus 7 over 2. That's it. Okay. Okay. So thank you.